Hi, good evening. So today we are going to discuss about one of the topic from the complex variables. That is about to find out whether the given function is analytic or not. Okay. So the question is find whether the function f of z is equals to x minus iy upon x square plus y square is analytic or not. Okay, so let us write what is given. The given function is f of z is equals to x minus iy upon x square plus y square. So it can be written as u plus iv, where u is the real part and v is the imaginary part. So therefore, from f of z, so u is a real part x upon x square plus y square, and v is the imaginary part, that is minus y upon x square plus y square. So now to find out whether the function f of z is analytic or not, first of all we have to find out the partial derivatives of u and v with respect to x and as well as with respect to y. So that is, you have to find out the partial derivative of u with respect to x and partial derivative of u with respect to y. Similarly, you should also find out the partial derivative of v with respect to x, partial derivative of v with respect to y. So, and find out whether the CR equations are satisfied or not. So, if CR equations are satisfied, then we say that the function f of z is analytic. Okay, so let us find out. So, once we have written the function and you have written the values of u and v, so that is the real part and imaginary part. Now we will find out the partial derivative of u with respect to x. So now u is x upon x square plus y square. So when we are going to find out the partial derivative of u with respect to x, we have to use the quotient rule. So we are going to find out the partial derivative of u with respect to x. So partial derivative of u with respect to x is equals to denominator square, denominator again, times partial derivative of the numerator with respect to x. So that is partial derivative of x with respect to x. So partial derivative of x with respect to x is 1. Then minus numerator into partial derivative of the denominator with respect to x. So denominator is x square plus y square. You have to find the partial derivative of x square plus y square with respect to x. So partial derivative of x square will become 2x plus partial derivative of y square with respect to x will become 0. So if you simplify this, x square plus y square into 1 is x square plus y square. 2x plus 0 is 2x. 2x into x is 2x square minus 2x square. So therefore x square minus 2x square will become minus x square plus y square upon x square plus y square whole square. So that is number 2. Now let us find out the partial derivative of u with respect to y. So again you have to use the quotient rule for this one also. Same denominator square. Again denominator into partial derivative of numerator with respect to y. So partial derivative of numerator is x, partial derivative of x with respect to y will become 0 minus numerator times partial derivative of the denominator with respect to y. So partial derivative of denominator with respect to y, derivative of partial derivative of x square will become 0 plus partial derivative of y square with respect to y will become 2y. So if I simplify this one, x square plus y square into 0, it will become 0. Here minus is there, x into 2y becomes 2xy. So 0 minus 2xy is minus 2xy upon x square plus y square whole square. So this is number 3. Now coming for v, partial derivatives of v. So partial derivative of v with respect to x. Again here also you have to use the quotient rule because we have here numerator and denominator. So therefore denominator square in the numerator, denominator into partial derivative of numerator with respect to x, partial derivative of minus y with respect to x, it becomes 0. Then minus numerator into partial derivative of denominator with respect to x. So partial derivative of x square plus y square with respect to x. So partial derivative of x square will become 2x plus partial derivative of y square with respect to x will become 0. So now after simplifying this, x square plus y square into 0 will become 0, minus into minus will become plus, y into 2x will become 2xy. So 0 plus 2xy upon x square plus y square whole square will become 2xy upon x square plus y square whole square. So this is number 4. Now let us find out the partial derivative of v with respect to y. So same, you have to use the quotient rule, denominator square, denominator times the partial derivative of numerator with respect to 1. So partial derivative of minus y with respect to y will become minus 1 minus numerator into partial derivative of denominator with respect to y. So partial derivative of x square with respect to y will become 0, partial derivative of y square with respect to y will become 2y. So x square plus y square into minus 1 will become minus x square minus y square, minus into minus will become plus, y into 2y it becomes 2y square. So upon simplifying, minus x square as it is, minus y square plus 2y square will become plus y square upon x square plus y square whole square. So this is equation number 5. So now from 2, 3, 4 and 5 you can see that partial derivative of u with respect to x, partial derivative of u with respect to x is equals to partial derivative of v with respect to y, partial derivative of v with respect to y. If we observe this too, minus x square plus y square upon x square plus y square whole square. Here also we have minus x square plus y square upon x square plus y square whole square. So 2 and 5 are equal. So therefore that is partial derivative of u with respect to x is equals to partial derivative of v with respect to y. And now partial derivative of u with respect to y, partial derivative of u with respect to y is minus 2xy upon x square plus y square whole square. So this is equals to minus of partial derivative of v with respect to x. So this one 3 and 4. So partial derivative of u with respect to y is equals to minus of partial derivative of v with respect to x. So therefore that means that CR equations are satisfied. So therefore we can say that the function f of z is analytic function. Thank you for watching my video, and if you like my video please hit the like button and kindly subscribe also and share with your friends that might be useful for them. Thank you so much for watching.